My name is Kaylyn Crawford, and I attended the Physics of Breakfast lecture by Peter Yonkers. I really enjoyed this lecture because I think it's really important to our education to apply a lot of the physics concepts that we're learning to even trivial circumstances as our breakfast foods. So in this lecture, the three items that were focused on were coffee, scrambled eggs, and Cheerios, and basically the physics phenomena that go along with some of the properties observed with these three foods. So first with coffee, if you've ever noticed that when you spill a cup of coffee and you'll leave it to sit, a ring will form. It won't just dry like flat. And the reason for that is because of surface tension. So basically the particles in the coffee are pushed to the edge of the drop to minimize surface tension. And as it dries, you'll see a ring that forms. And that's basically how that happens. Next with scrambled eggs. Scrambled eggs is an example of soft matter because it's not necessarily a perfect liquid or solid, yet unlike a liquid where when it's heated it will evaporate at a certain temperature, it turns more to a solid when it's heated. And that's basically due to its protein content. Eggs are high in protein, as we know, and proteins have hydrophilic and hydrophobic regions, and basically these can unfold when heated, but not in an orderly manner. And so as you heat the proteins, they become denatured, and that adds kinetic energy to them, which allows like some of the hydrophobic regions to sort of pop apart, not in an orderly fashion. So basically you end up with like a long chain of networks of denatured proteins that have elastic behavior, and that's sort of how you have the weird sort of squishy property that eggs have. Lastly, with the Cheerios, if you've ever noticed, like as you're eating cereal, sort of at the end when you have Cheerios in a bowl of milk, they won't just be scattered, randomly throughout the milk. They'll sort of clump together, and that's due to the property of adhesion. So basically, when fluid and solid molecules are in contact, the fluid molecules are attracted to the solid, and they form a meniscus. Because Cheerios are less dense than the milk, they tend to want to sit at the highest point on the milk surface, and this creates an upward shaped meniscus on the Cheerio. And so basically when two or more Cheerios come together, their effective meniscus increases and puts them at an even higher point on the milk surface, which also allows for less deformation of the milk surface. And so when I thought about this some more following the lecture, I thought that reminded me of the concept of entropy and the measure of like disorder of a system. So I thought it was really cool how the Cheerios tended towards a state of less disorder on the milk surface as opposed to just being scattered all over the milk, which I thought was really cool. Also, I thought it was really interesting how even though we applied physics concepts to breakfast foods, these same phenomena that occur with these different items, especially with coffee and the idea of surface tension and the forming of the ring, could be applied to malaria research and also Alzheimer's research, which I thought was really cool because it's really important to sort of branch different topics into different areas of research.